Hello friends, welcome to Quick Learn website, and I am very excited to inform you that in Quick Learn I have recently launched my website, that is www.quick-learn.in. This website is especially for all the engineering and diploma students and those students who will preparing for competitive exams. So in the blog section of the website, you can find the notes of all the electrical and electronic subjects, just like basic electronics, microcontroller, microprocessor, power electronics, and slowly I will add more notes in the website. And if you are preparing for any government competitive exams, then check also my MCQ series, that is multiple choice question series, and previous year question papers. That will help you in your competitive exams. Here I also upload the quiz test or mock test for ONGC, UPPCL, or for different type of competitive exam previous year question papers. Or for latest update, please join my Telegram channel. The link of my Telegram channel I will give in my description box. So stay continue and keep watching and keep visiting my website. Hello friends, welcome to Quick Learn tutorial series. In this video, I will explain you Class C Commutation of SCR, its circuit diagram, working and waveform. This is lecture number 46 of Power Electronics series. So let's start with the topic. Before I discuss Class C Commutation of SCR, we must know about what do you mean by commutation. Commutation is basically a process of turning off any device. Or in terms of SCR, we can say that the turning off process of SCR is known as SCR commutation. There are basically two types of commutation technique. First is natural commutation and second is force commutation. So class C commutation is come under the category of force commutation. In case of force commutation, we turn off SCR forcefully with the help of external circuitry. So here we use class C commutation circuit to turn off the SCR. That is why it is called class C force commutation technique. Okay. Now class C commutation is also known as voltage commutation because in this technique, here we apply a reverse bias voltage across the thyristor and thyristor get turned off. That is why it is called voltage commutation. Class C commutation is also known as complementary commutation because here we see in the circuit diagram of class C commutation, here we use two thyristor T1 and T2. First we turn on T1 thyristor by applying a gate current and T1 thyristor get turned on. If we want to turn off the T1 thyristor, gate pulse is given to T2 thyristor and T2 thyristor get turned on. If we want to turn off T2 thyristor, we apply gate triggering pulse to T1 thyristor and T1 thyristor get turned on. So this complementary action will perform here. That is why it is called complementary commutation. Here we see class C commutation is also known as complementary commutation because as I have already told, first we turn on T1 thyristor. To turn off T1 thyristor, gate pulse is given to thyristor T2 and to turn off thyristor T2, gate pulse is given to thyristor T1. So this is the complementary action will be performed here. That is why class C commutation is known as complementary commutation. Okay. Now circuit diagram of class C commutation. This is the circuit diagram of class C commutation. Class C commutation is basically a type of force commutation. And in any force commutation circuitry, the supply voltage is DC supply voltage. So this is the reason we use DC supply voltage Vs at the input side. Here we use two thyristor T1 and T2. T1 is the main thyristor and T2 is the complementary thyristor. Here we use a commutating component capacitor in between two thyristor T1 and T2. Here we also use two resistors R1 and R2. So this is the whole circuit description of class C commutation. Now we move on the working of class C commutation. Initially, we assume that both the thyristor T1 and T2 is turned off. So both thyristor is behave like a open switch, and initially voltage across capacitor is 0. Vc equals to 0 because there is no path of current to flow across the circuit. Then first we turn on T1 thyristor by applying gate triggering pulse. When we apply gate triggering pulse to T1 thyristor, T1 get turned on. So there are two loops through which current flow through the T1 thyristor. First loop is current flow through supply voltage R1 resistor, T1 thyristor and back to the supply voltage. This is loop 1. And the second loop is current flow from supply voltage R2 resistor through capacitor T1 thyristor and back to the supply voltage in this direction. This is loop 2. So the current flow through loop 1 is called I1 current, and this current is Vs by R1. Okay. Now current flow through loop 2 is called I2 current, and I2 current equals to Vs by R2. So the total current flow through the T1 thyristor is equals to I1 plus I2 Vs upon R1 plus Vs upon R2. This is the total current flow through T1 thyristor. Now here we see in the circuit diagram, when current flow through loop 2 from resistor R2 through capacitor start charging. When capacitor is charged, the current through loop 2 get decreases. When capacitor is fully charged with supply voltage Vs, the current through loop decreasing to 0. And when loop 2 current decreasing to 0, how much current flow through T1 thyristor this time? So T1 thyristor current is equal to the loop 1 current, that is equals to Vs by R1. This time loop 2 current becomes 0 because capacitor is fully charged with Vs supply voltage. And when capacitor fully charged with Vs supply voltage, current across loop 2 is decreasing to 0. So the total current flow through T1 this time equal to Vs by R1. So when capacitor is fully charged with Vs supply voltage, the polarity across capacitor is right side plate is positive and left side plate is negative, and capacitor charged with Vs supply voltage. This time this polarity of capacitor will turn off T1 thyristor because the negative of capacitor is connect from the anode of the T1 thyristor. That will make T1 thyristor turn off. Now we apply a gate triggering pulse to T2 thyristor, and T2 thyristor get turned on and behave like a closed switch. Now we have to calculate how much current flow through the T2 thyristor. When T2 thyristor is turned on, so there are two loops through which current flow through the T2 thyristor. One loop is from supply voltage R2 resistor, T2 thyristor and back to the supply voltage. This is loop 1 through which current flow through the T2 thyristor. And the second loop is supply voltage R1 resistor, capacitor, T2 thyristor and back to the supply voltage. This is loop 2. So initially total current flow through T2 thyristor is current flow through loop 1. How much current flow through loop 1? Vs by R2. This much current. Okay. Through R2 resistor. Current flow through loop 2. So the total current flow through loop 2 is 2 Vs by R1. Why it is 2 Vs? Because Vs supply voltage and capacitor is also charged with Vs voltage. So the total voltage is Vs plus Vs 2 Vs by R1. Initially the total current flow through the T1 thyristor is Vs by R2 plus 2 Vs by R1. Now here we see in the diagram, when current flow through loop 2, capacitor is again charged with polarity. Left side plate is positive and right side plate is negative because current flow through loop 2 in this direction. So capacitor again charged with supply voltage Vs, but this time the supply voltage Vs polarity is negative. So when capacitor start charging with Vs voltage, slowly current across capacitor start decreasing. And once capacitor is charged with minus Vs voltage completely, the current through loop 2 is decreasing to 0. Here I mention, once capacitor is charged with plus Vs to minus Vs voltage, current through loop 2 is 0. This time only current will pass through T2 thyristor is through resistor R2 from loop 1, that is equals to Vs by R2. Loop 2 current is 0, so the total current through T2 thyristor is Vs by R2. And the polarity across capacitor this time is left side plate is positive and right side plate of capacitor is negative. And capacitor is charged with minus Vs voltage. Now, when capacitor is charged with minus Vs voltage, the polarity across capacitor is this time this polarity of capacitor will turn off T2 thyristor, because the anode of T2 thyristor is connected from the negative of the capacitor. That will make T2 thyristor turn off and T2 thyristor behave like a open switch. This time again we apply gate triggering pulse to T1 thyristor and T1 thyristor again start conducting. Again current flow through T1 thyristor from two loop. One loop is through R1 resistor, R1 T1 and back to supply voltage, and the second loop is through R2 resistor, capacitor, T1 thyristor and back to supply voltage. It means again we come to its initial condition. So this is the whole working of class C commutation. Now I will explain the whole working with the help of waveform. This is the circuit diagram of class C commutation, as I have already explained you. Here we use Vs supply voltage, two thyristor T1 and T2, one commutating capacitor C in between two thyristor and two resistor R1 and R2. These waveform we have to draw. Ig1 is the gate current waveform we applied to thyristor T1. Ig2 is the gate current of thyristor T2. Vt1 and It1 is the voltage and current across T1 thyristor. Vt2 and It2 is the voltage and current across T2 thyristor. Vc and Ic is the current or voltage across capacitor. Now, first we consider at omega t is equals to 0, we apply a gate triggering pulse to thyristor T1 and T1 get turned on. When T1 get turned on, it behave like a closed switch. So there are two loops through which current flow through the T1 thyristor. First loop is from supply voltage R1 resistor, T1 thyristor and back to the supply voltage. This is first loop through which current flow through T1 thyristor. And the second loop is supply voltage through R2 resistor, capacitor, T1 thyristor and supply voltage. This is loop 2. So first we calculate how much current flow through T1 thyristor. Okay. So initially current flow through loop 1 is we called I1 and that is equals to Vs by R1. Now initially current flow through loop 2 is I2, that is equals to Vs by R2. So initially the total current flow through T1 thyristor is Vs by R1 plus Vs by R2. Okay, this is the total current initially flow through the T1 thyristor. So now we start drawing the waveform. First we apply gate triggering pulse to thyristor T1. T1 get turned on. When T1 get turned on, the voltage across T1 is 0, because we know that when device is turned on, there is no voltage drop across the device. So Vt1 is 0, obviously. Okay. Now what about It1? So initially when T1 is turned on, initially the current flow through T1 is Vs by R1 plus Vs by R2. We take Vs common. So Vs 1 upon R1 plus 1 upon R2. This is the initial current flow through the T1 thyristor. Now after that what will happen? Here we see in the circuit diagram when current flow through loop 2 through R2 resistor through capacitor start charging with polarity. This terminal is positive and this terminal is negative. When capacitor start charging, the current flow through loop 2 start decreasing, and when capacitor fully charged with Vs supply voltage, the current flow through loop 2 is decreasing to 0. When capacitor is completely charged with Vs supply voltage, here I mention the loop 2 current is decreasing to 0. That time total current flow through T1 thyristor is only from loop 1, that is Vs by R1. So here we see in the waveform, initially how much current flow through T1 thyristor? This much. Vs 1 upon R1 plus 1 upon R2. When capacitor slowly charged with Vs supply voltage, current across T1 thyristor get decreasing because loop 2 current is decreasing. And when capacitor is fully charged with Vs voltage, at this time instant, loop 2 current is decreasing to 0. At this time, the total current flow through the T1 thyristor is Vs by R1. So here, this magnitude is Vs by R1. Simultaneously, we draw the waveform of Vc and Ic. So here we see, here capacitor, when current flow through loop 2, capacitor is slowly charged with some voltage. At this point, capacitor is charged with maximum Vs voltage. And when capacitor is charged with maximum Vs voltage, current across T1 thyristor is Vs by R1. Now what about the current through across capacitor? When capacitor voltage start built up, the current across capacitor start decreasing. Okay, so at this point, when the capacitor is charged with maximum voltage Vs, the current across capacitor is 0. Now what about the voltage and current across T2 thyristor? So T2 thyristor is turned off this time, and when T2 thyristor is turned off, the voltage across T2 thyristor is maximum. We get maximum voltage drop across the device, that is equals to Vs. And because T2 is turned off, there is no current flow across T2 thyristor, so this is 0. So this is the waveform of mode 1. Now what about mode 2? So mode 2 start from T1 time instant. At T1 time instant, here we see capacitor is charged with plus Vs voltage. When capacitor is charged with plus Vs voltage, this polarity of capacitor will turn off T1 thyristor because the negative of capacitor is connected from the anode of the T1 thyristor, and this will make T1 thyristor turned off. Now we apply gate triggering pulse to thyristor T2, and T2 get turned on. When T2 get turned on, it behave like a closed switch. Now again current flow through T2 thyristor from two loops. First loop is from supply voltage R2 resistor, T2 thyristor, and back to the supply voltage. This is loop 1. Loop 2, current flow from supply voltage R1 resistor through capacitor, T2 thyristor, and back to supply voltage. This time, how much total current flow through T2 thyristor we have to calculate. Current through T2 thyristor, initially current flow through loop 1. Loop 1 is through R2 resistor. So how much current flow through loop 1? Vs by R2. Initial current flow through loop 2, that is equals to 2 Vs by R1. Why it is 2 Vs? Because Vs is the supply voltage and capacitor is also initially charged with Vs voltage. So Vs 2 Vs upon R1. So this is 2 Vs by R1. Current flow through loop 2 initially. Okay, so initially total current flow through T1 thyristor is Vs by R2 from loop 1 and 2 Vs by R1 loop 2. So now we start draw the waveform. At time instant T1, we apply gate triggering pulse to thyristor T2. T2 get turn on and behave like a closed switch. This time T1 is turn off due to the polarity of capacitor. When T2 get turn on, the voltage across T2 is 0 because T2 is turn on. So here we see VT2 waveform, voltage across T2 thyristor is 0. What about voltage and current across T1 thyristor? T1 thyristor is turned off this time. So when thyristor is turned off, we get maximum voltage drop across thyristor. So here the voltage across T1 thyristor is Vs. What about current through T1 thyristor? T1 thyristor is turned off this time. Current across T1 thyristor is 0. T2 thyristor is turned on. So voltage drop across T2 thyristor is 0 this time. What about current through T2 thyristor? So initially when we turn on T2 thyristor, current flow through T2 thyristor from two loops 1 and 2. So the initial current flow through T2 thyristor is this much. Here we mention this much current, Vs 2 upon R1 plus 1 by R2. This much current initially. After that, when current flow through loop 2, capacitor is start charging with polarity. This plate is positive and this plate is negative because current flow in this direction. When capacitor start charging, the current through capacitor start decreasing. It means the loop 2 current start decreasing. And when capacitor is fully charged with minus Vs voltage, the current through capacitor is 0 or loop 2 current become 0. Okay, this time once capacitor is charged with plus Vs to minus Vs voltage, current through loop 2 become 0. This time the total current passed through T2 thyristor is from loop 1 only, that is equals to Vs by R2. We see in the waveform, initially current is maximum this much. Okay, when capacitor start charging with minus Vs voltage, current across T2 thyristor get decreasing. And when capacitor is completely charged with minus Vs voltage, the current across T2 thyristor is Vs by R2. So here this magnitude is Vs by R2. At this point, capacitor is completely charged with minus Vs voltage. So here we see in the waveform of capacitor, this point capacitor is charged with minus Vs voltage. So this is the time duration where capacitor is charged with plus Vs to minus Vs voltage. Okay, after that capacitor will hold minus Vs voltage. At this time duration, current across capacitor is maximum this time. And when capacitor start charging with minus Vs voltage, current across capacitor start decreasing. And when capacitor is fully charged with minus Vs voltage, current across capacitor reduced to 0. So here this waveform is 0. At this time instant, T2 time instant, here we see capacitor voltage is minus Vs. It means capacitor this time is charged with polarity. Left plate is positive and right plate is negative. Okay, capacitor this time at T2 time instant, capacitor polarity is this. This polarity will turn off T2 thyristor because the negative of capacitor is connected from the anode of T2 thyristor. That will make T2 thyristor turn off and T2 behave like a open switch. Now we again give firing pulse to T1 thyristor at time instant T2. So T1 thyristor get turn on and T2 thyristor get turn off. It means we again come to the initial condition. Here again the whole process is going on. So this is the whole working of class C commutation. If you like video, please like, subscribe and share my channel. For notes, please visit my website. The link of the website I will give in my description box and I display here also, www.quick-learn.in.